a probability distribution for a discrete random variable. So we're going to focus on discrete random variables today. And so we've got a discrete random variable. We're influenced by the times buyers of product have watched TV before purchasing a product. So number of times they watch an infomercial. That's a discrete variable because you couldn't watch it like 1.5. Okay, and so what we've got to do here is we've got to find and first off we got to see if it's a valid probability distribution, and then compute the mean standard deviation. Okay, and let's moment. All right, so how do we find? We are going to first see, is this a valid probability distribution, and you're be asking what to add up to for all the probability distribution. 100%. So just checking that it adds up 100 decimals, then it's not a valid probability distribution. So this is a valid probability distribution. They're mutually exclusive, meaning you can't watch it two times. So the formula for the mean is it's sigma of x times p of x. What does this mean? This means the sum of each x times the probability. So 1 times the probability of 1, and you convert it to a decimal. So 1 times 0.27 plus 2 plus you do the 3, the next one, times the probability of that outcome, plus the next value times the probability of that outcome. This is called the expected value. You could also call this the mean of the distribution. So basically you're taking each so 1 times 0.27. There is a way to do this in the calculator. So if you don't like this way, I could show you another way. Times 0.09 plus 5 times 0.15. Whoops. It's 2.54. So that's the mean. How do I do standard deviation? Okay, standard deviation, it's sigma. It's the sum of the differences between each. What does that mean? Okay, so I'm going to do a square root, and guess what? This is going to be a large square root. Okay, so it's the sum of each squared times the probability of x, probability of that outcome. So I'm going to do this for each mean squared times the probability for that outcome, plus the next one, 2 minus 2.54 plus the next one, which is 3 minus 2.54 squared times 0.1 minus 2.54 squared times 0.09. So this is too stressful for you. You could also do this in the calculator. So what I did was each x value minus the mean times the probability attached to that. So like 3 minus the mean value squared would be a little bit of a pain. So you're going to have to do the square root of open parenthesis 1 minus. I'm a little scared I'm going to get this wrong. Times 0.27 plus 2 minus 2.54 squared plus 3 minus 2.54 squared times 0.18 squared times 0.09 plus 5 minus 2.54 squared, and I get 1.366. I'm not sure how they want this to round. I didn't really say. 1.3. Do you have to know how to do that? No, because there is another way to do this. I'm going to talk about this. So here's the other way to do this. You go to stat edit. Okay, so stat edit, and you enter press clear, press down, and then I'm going to enter the X's and L1. These are the X's and L1. Okay, make sure that it looks like in 4 and L1, and the okay. So I'm going to do these as decimals, not percents. Okay, so on my X list, I'm going to have 1, 2, 3, 0.27, 0.31. So I convert these to decimals because that's what they are as numbers. L2. Then I'm going to go to stats. So stat calc 1 bar stats. So stat calc 1 bar stats. 1. Okay, now we're going to do something we've never done before. We're going to put something in for the frequency list. My frequency list is L2. That's of L2. Why am I doing that? Because this tells you how frequently each outcome in L1 happens. So option 1 happens 27% of the time. So this tells you that list in L2 tells you how frequently each outcome in L1 happens. Okay, so and then the standard deviation is right here. So it's just the same as what I did get it by hand. That's how we can do it in the calculator. So you kind of choose which way works best for you.